Ready? Take your break. Restroom break. Changed. Okay. Okay, good morning, pharmacy. Let's do the answers for your homework for manual IV calculation, the 6 pages. Answer to prescription 1 is 50. We did that on the board yesterday. Number 2, answer, Kaylin. Which one? 18. I don't have 18. Final answer must be whole numbers, round down. That's what we agreed on yesterday, right? Okay. Order 500 ml of IV solution with 100 units of heparin to infuse at 10 units per hour. The drop factor is 15 drops per ml. What is the flow rate? So flow rate for this one would be, formula would be R equals V over T C, which is the same as R equals V, right? Okay. Any other answers, Clyde? 12. My answer is 12. Okay. Who got 12? Okay. For the ones who weren't here, Katie wasn't here yesterday. So this is how I did it. There'll be 500 ml, right? For the prescription. You'll figure out what you did wrong, okay? And then you know that this is volume, correct? And then there's another given in the prescription, which is the drop factor constant. So that's your C, correct? And that is 15 drops per ml. Now, what's missing in the formula? What's missing is T, correct? In likely minutes or hours. Okay, usually you choose the minutes. How do we do that? Well, there's another set of numbers that's given in there. You see, Kaylin and Camille, which is 100 units, but it's saying that 10 units per hour of heparin, which is the factor that you're going to use. 10 units per hour, infusing at 10 units per hour. But you need to infuse 100 units of heparin. This is where your ratio and proportion comes into play. See that? That's how you get the time, okay? Which is 100 divided by 10 should give you 10 hours. Okay? You want to convert this 10 hours to minutes, it becomes what? It becomes 600 minutes. Now, do you have the T? Yes, you have the T. Okay, can we plug in the numbers? Yes. Okay. Actually, you just did the math. Okay. There's the rate. You gotta calculate the rate still, right? And what is the rate? VC over T. And what's your V? Are you still following me? Me, Caitlin? This will be your 500 ml. What's your C? This is your 15 drops per ml. Now you can see that you can cancel ml right off the bat, right? And what's your T? 600 minutes. You see that? So it'll be 500 times 15 equals divided by 600 should give you an answer of 12.5, I think. Yes, 12.5, but the rule was to drop that decimal. So our final answer will be 12 drops per. I's answer is correct. You see? Now you know. You cross multiplied at the end. Oh, okay. Just cancel this. Just proceed. Did you see how yesterday I transposed all the formulas in the video? Okay. Any questions here? Fine. Number 3.
3 is going to be 7.
Correct. 7 what?
7 drops per minute.
Correct, because we're looking for the flow rate. Your answer will come up to 7.5, but the rule that I gave you was round down. So final answer is 7 drops per minute. Who got this one? Hands up. Good job. Number 4, Kyle.
33.
Correct. It's 33.33. Again, drop the decimals. So it's 33 drops per minute. Who got this one? Hands up. Okay. Number 5, Jordan. No, I don't have that. Any other answers? Roxy.
1 drop.
1 drop per minute. Jordan said, what the hell? Okay. Can you figure it out? I want me to do it on the board. How many did not get 5 correct? I'll do it on the board if you did not get 5 correct. Okay. Camille was out yesterday, so let's try it. Number 5, you got a volume correct? 50 ml, you got your B there, normal saline. And then you have a drop factor constant, which is a C, 20 drops per ml. Again, you're looking for the R, because it's the flow rate, but you have to solve for T first. Follow? There are givens in the T that you can use, which says same, 10 units per hour infusion, but you need what? 100 units, right? So how do you do this? 10 units for every hour proportion. 100 units is to X hours. What is this again? 10 hours first, because you're left with hours. If you want to make it to minutes, it becomes 600 minutes, correct? Now you have the time. Now you can proceed to the calculation, correct? So what's your V? 50. What's your C? 20 drops per ml. And what's your T? 600 minutes. Cancel the units. ml you can cancel. You're left with drops per minute. And that gives you what? 1.66, 1.6.
In my minutes. I think because the U, I like the 0 looks like a U. I think I got it right.
Exactly.
Yeah.
Okay. The U for unit is one of those. Do not use this by the TJC for that reason, because it can be misread as a 0. You're in a hurry.
Yeah, it looks like I closed it.
Exactly. Now you're experiencing it, and now you know the rationale behind why we should not use, or doctors should not use, the letter U as an abbreviation anymore. Part of that, do not use this. Okay, ready? Number 5. Did you understand, Camille? You got it this time? Okay. Number 5 is correct. 1. Number 6, Leslie. Oh, we did it on the board. No, we didn't. Number 6. Correct. Who got 56 drops per minute? Everybody? I saw Keelan's face. You want me to do it, or you figured what you did wrong? Now's the time. You can do it? You want me to do it? Okay. So break it down again. Same flow rate, still the question, which means R is still missing, right? Okay. Similar problem. Don't get thrown off by the half normal saline. It's just telling you what IV bag to use. Okay? That half doesn't matter in this calculation. So we have a V. The V, Kaylin. What's my V? Right, that's where you got it. What's the V? You already figured it out. Right there. Number 6. I can move on. See how that 0 mattered? What's the V? She said 300. What's the V on a prescription? That's your missing 0. Now you get it? So you didn't do the process wrong. You wrote the number wrong. And that is a problem too in the calculation. Again, who got 6 correct? 56. So what was your answer? 5.6. There you go. You answered your own problem. Number 7. Did I call you Roxy? Jennifer. Who got 1 drop per minute? It's actually 1.5. Okay. But we got to drop that 0.5 as a rule. You got that one, Caitlin? Yes. Okay. Everybody did? Okay. Vanessa, number 8. Correct. It's 66.67. So with the rule round down, 66 drops per minute. Who got that one? Hands up, please. Okay. Number 9. Camille. You did not get? Okay. You didn't get to do, or? I didn't get to do. So you're not yet done with the worksheet? Okay. Okay, let's do number 9. It's not that you're wrong. You just didn't do it. Okay. Jennifer, number 9. So I'll move on, okay? You just have to catch up because we have one topic today.
75 drops per minute.
Correct. Who got 75 drops per minute? Hands up. Okay, good job. But Camille, do you understand? Yeah. Okay. Number 10. Kaylin. Correct. It's 6.25. So drop that 0.25. It's 6 drops per minute. Prescriptions 1 to 10. The first 2 pages are all flow rate. Finding the R. See that? 11 I did on the board yesterday, correct? Prescriptions 11 to 20. The question on the problem was, how long will it take to infuse, which means you're missing the time. Okay? So if we are to transpose this, R equals BC over T, this will be RT equals BC. But we're looking for the time, so let's do it this way. Yes? And then I'll put it in here. Did I memorize the formula for time? No. I just derived from the formula that I know, right? Which is R equals B over T times C. I'd like to leave it there so that it's faster when I calculate. You can do that on your test paper. Okay. Okay, number 12, answer. Roxy.
1 hour and 40 minutes.
Correct. It's 1 hour and 40 minutes, which is 100 minutes. Who got that one? Okay. Your test will have hours and minutes. So I want you to know how to convert your leftover remainder. And this is what I do. Say, for example, I have here 10.25 hours as my final answer, right? That's not acceptable if it's in hours and minutes. I get this portion, the 0.25, because that 0.25 means 25%, right? So what I do, I'll extract that times 60. It tells me how many minutes, because that's 25% of an hour. You see that? And now you can calculate that this is what? 15, right? So this means this is 10 hours and 15 minutes. You follow? That's how simple it can be. Okay. Because I peeked at your final exam, it's hours and minutes. Who got hour and 40 minutes? Hands up again, please. Okay, good. 13, Clyde.
2 hours, 5 minutes.
Correct. It's 125 minutes converted to hours and minutes. It's going to be 2 hours and 5 minutes. Who got that one? Hands up. Okay, Jordan, redeem yourself, number 14.
I got 750 minutes.
Correct.
12 hours. And 3 minutes.
Very good. Who got that one? Hands up. Good, good, good. Number 15, Leslie.
Sorry.
You're fine.
43 hours.
You're short. Short. You said 30 minutes,
23 hours.
23 hours and 30 minutes. You're short. Kaylin. Those. Because I know there's going to be a discrepancy. I know what you mean. Because it's going to be 1,411.76 minutes, correct? But you can do 1,412 minutes, which translates to 23 hours and 32 minutes. If Kaylin showed that solution on the test, I will consider her answer, even if my answer key says 23 hours and 32 minutes. Okay, because it depends. If you cut it off on the 1,411.76, you will have a little bit of a discrepancy. Okay, if you show your work and I see what you did, now I can get it. But not 30. Should be 32.
So you don't round down when you get an answer to that.
Oh, this is time. This is different.
No, okay.
Yeah, this is time. So this is different. Who got 23 hours and 32 minutes? No? Should we do it on the board? 31 is fine. Because it depends if you cut it on 1,411.76 or you left all the numbers or you round it up to 0.8. What was your answer?
It was 30, but you, like, would you take like 30?
It becomes 32. Yeah. Because this is not the same as drop. It's hard to picture a 1.5 drop, right? This is time. So you can round up on the time part. Okay? You can round up on the time part. As long as you show your work, I don't care about the answer key. If it gets to that. Yeah. That's why I said, you're too close. If you showed your work on a test, I probably would give you that one. Yeah, because I'm going to see where you cut it off, where you round it off. Okay. Number 16, do you need to adjust any of these since I mentioned that today? No? Okay. 16, Jennifer.
6 hours and 15 minutes.
Correct. It's 375 minutes converted to hours and minutes. It's 6 hours and 15 minutes. Who got that one? Hands up. Good job. Back to you, Stefan. Number 17.
17 hours, 307 minutes.
Oh, you convert. I'll wait. Don't give me that excuse. I did not convert. I told you the finals is hours and minutes. I wanted to see that you can do it. So what do? Divide by 16, then you're going to have a decimal. And what do you do with the decimal? I told you, multiply that by 60. Let's see if Stefan knows how to convert minutes to hours. Am I recording? Panopta was taking a while yesterday, so I just put in the YouTube processed faster. Like I always have backups. Because I know Jennifer would be so in a hurry to look at that video. to figure out this homework. It's okay, I'm just teasing, playing with you.
5 hours and 9 minutes.
No! Where did that come from? Okay, perfect example. Let's do this. You said how many minutes total? 357 minutes, correct? Yes. So what we can do is convert it to hours. 1 hour is 60 minutes. Now you can cancel this, right? You can figure out the hours. So 357, look, Stefan. 357 divided by 60 should give you 5.95 hours, right?
Yes, that's what I know.
Right, but that's wrong. I told you what you do with this one, 0.95, multiply that by 60, right? Your 5 hours already and 1 minutes. So your 0.95, it means that 95% of 60 minutes is what? You get it? That's why I do it this way. 0.95 times 60 is 7 minutes. Did you see that? How I did it? Okay. I considered this as a percentage of an hour, 60 minutes. Who got 5 hours and 57 minutes? Hands up. Good job. Kyle, 18. There you go, jackpot. Okay. Who got 13 hours and 53 minutes? Good. 90 and Jordan.
1 hour and 7 minutes.
Correct. Who got 1 hour and 7 minutes? I saw Kaylin. This. Are you off by 1 minute? Yes. It's 67 minutes on mine. So 1 hour and 7 minutes. Who got 1 hour and 7 minutes?
So do we keep the decimal? Because I didn't round, that's why I got 6 minutes.
It's okay, as long as you show your work. Okay. I keep it because it's time. It's not drop. Right? The fractions, I mean the decimals matter on time. You see how this mattered?
Yeah.
Because a quarter of an hour is 15 minutes, so that matters. Even if it's 0.25, that matters because that's 15 minutes equivalent. That's why I keep it. Round up, and then when we're talking time, very specific. So my answer is 1 hour and 7 minutes. Did you make the adjustment? Yes, in your brain, on your paper? Yes. Okay, number 20, Roxy.
250 minutes.
Correct.
4 hours and 10 minutes.
Correct. Who got that one? 250 minutes, which is 4 hours and 10 minutes. Number 21, we did it on the board yesterday. Answer is 1,350 ml. You weren't here, but it was on the video yesterday as well. Let's do this. Now the question is, how much will the patient receive? Which means volume. And your answer should be in ml. Well, I don't memorize this formula, but I know this. So let's go back again. So if this is the formula, R equals VC over T, I want to get the volume. This becomes RT equals VC. Divide both sides by C. Now I have a volume formula, right? Which is RT over C. You follow? What if there's no constant? Then take out the constant. Then it just becomes R times T. You follow? Remember, the constant is not always there. Okay. Now we have a working formula. It's faster and easier to perceive. Camille and Caitlin, did you get this part in the video? Okay. It's just transposing from the original. From the original. Yeah. I know. Did you watch it? Go back, replay, rewind me over and over. Okay, that's why it's there. Okay, and she's sick yesterday, so okay. Not an excuse though. You know me. Okay, prescription 22. IV is infusing at 55 drops per minute, and the drop factor is 10 drops per ml in 24 hours. How much will the patient receive, Jennifer?
7,920 ml.
Correct. Who got that one? 7,920 ml. Remember, when you get to this point, the answer is in ml. Okay, this one, minutes, depending on what's being asked of you, or hours and minutes. This one, it's going to be drops per minute or now per. Who got 7,920 ml? Hands up. Okay. Vanessa, 23. Correct. Who got 1,440 ml? Good job. Leslie, 24. Correct. Who got 180 ml? Hands up. Woohoo. Number 25, Clyde.
854.
Correct. Who got 864 ml? Label, 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 label. You put the unit of measure. Even if you got the 864 correct, if you didn't write what it is, I'll mark you wrong. So you wasted that effort. Number 26, Kaylin. Correct. Who got that one? 2,560 ml. Okay. Are you caught up, Camille? Not yet. This part, the volume part. Okay. The volume part, you can plug it in here as an X, or you can get the formula for the volume, which is this one. Number 26. Want to do 26? Okay. IV is infusing at 80 drops per minute. What is it if I'm to label that? The drop factor is 15 drops per ml. What is this, Camille? Help me label this. What is it? Correct. And this one would be C. Okay. Are there other info that's in here? What is that? If I'm to calculate what's missing, the volume, follow, which means my answer will be in ml. And this is in minutes. The first thing I do is to convert this. Apples to apples. Okay. It's just easier to convert this to minutes than convert this to hour. Right? It makes sense, right? But it has to be apples to apples. So what is this in minutes? 60 minutes over 1 hour dimensional analysis, this becomes 480 minutes. Now, do I have a working equation to plug in here? Yes, my R, 80, I still write it, you see, because I want to see that I'm doing the right thing. What's my T? 480 minutes. You see how I can cancel the minutes now? There you go. And then, what's my C? 15 drops per ml. You see how I can cancel my drops now? Now what am I left with? It's just validated that you're doing the right thing. Okay. 80 times 480 equals divided by 15 would be, Camille. Very good. Okay, who got 2,560? Hands up. Kaylin, 27. Good job. Okay, who got that one? 1,992 ml. 28, Roxy. Who got 600 ml? Hands up. Good job. Number 29, Jennifer. Correct. Who got 160 ml? Okay. Jordan, number 30. 670. Who got that one? Hands up. Good job. Okay. Who got everything correct? Not for the minutes. Not for the minutes, because you didn't clarify yesterday that no, we don't drop it, okay, for the minutes, because time. You see how important a quarter of an hour is? That's 15 minutes. But we drop it for the drops, for the drop factor, okay? Because it has to be a whole number. Next set of worksheets. So if you did that, more complicated than this second sheet, this one is just V over T. Yeah, no constant. Okay, usually the ExCPT. Okay, this will come up again if you are going to take the CPhT certification. This has something to do with sterile compounding, IV, dose flow rate, and drug rate. Okay. it is important that we know how to calculate this, and it still comes up on test, even if the bulk of this responsibility falls under the nurse. Okay. Number 1, here, whole number as well. Okay, whole number as well. See, I have so many erasers on my answer key, and I have a note on top. This is ml per hour, which is quantity to be dispensed. I have here round up, final answer. No, I'm not going to do that. Want it to be consistent. So we're just going to drop whatever the decimal is. Okay. But my answer key is still on a round up. Number 1, Clyde. Pump infusion, IV calculations. The two pages only, right? 10 questions.
Yeah.
83 ml per hour. Who got that one? Hands up. Okay, good job. Number 2, Leslie. Same, 83 ml per hour. Number 3, Vanessa. 46 ml per hour. My answer key says 47 because it followed the round up before. Okay. 46 ml per hour. Number 4, Kaylin. Correct. What? Correct. Who got 71? Hands up. Number 5, Jennifer.
16 mL.
Too far. If it's just like 1 increment, I'd be fine with it. It's different. Do it again. So V over T. It's in hours. That's how it got you. And the given is in minutes. So you got to convert that given 33 minutes into hours first. You follow?
Yeah.
Okay, what is your answer? Dimensional analysis, you like it?
Yeah.
So convert your 33 minutes to hours. And you can use the decimal for this calculation because it's not 33 divided by 60, which my calculator. This is your hour. What is the answer? 0.55 hour. Okay. Now can you plug it in to the formula V over T? Yes. What's your V? Is it an ml already? Yes. And what's your H? 0.55. Has to be the correct unit. Did you see that?
Yeah.
What's the answer?
90.
90 or 91, depending on where you cut it off. Okay. Who got 90 or 91 ml per hour? Hands up. I told you there will be a discrepancy, so you want to show your work to me when faced with problems like this. Number 6, Vanessa. Correct. 150 ml per hour. Apples to apples right away. It threw you off because it gave you in minutes. Okay. Who got 150? Hands up. Roxy 7. 31 ml per hour. Who got 31? Hands up. Okay. Camille, number 8. Correct. Who got 100 ml per hour? Good job. Number 9, Kaylin. That there's going to be a discrepancy again on this one. I'll accept both answers. Okay. Number 10. Come again. Number 10, Leslie. Correct. Who got 52 ml per hour? Just waiting on Kaylin for number 9. Yeah, 166 or 167 ml per hour. Who got that one? Hands up. Who got all 10 correct? Hands up. Okay. Make the necessary adjustments in your brain on the time and on your paper. Okay. We'll continue with overfill. 2 minutes break. This is a different topic, but it will be 1 page of your final exam. 2 minutes, overfill. You gotta take notes because not everything is in. I'm gonna tell you things that come up on a PTCE. I thought that book will be short. It's long. 1,000 questions. So proofreading. But it's going to be the best reviewers that you'll have. One minute. Who's staying after class? Oh, good job. Is the prescription I gave you mindful money? Let's start. I'm going to talk about 3 numbers that you need to remember. In compounding, and I'm going to tie this to your compounding class, pharmacy lab skills. You're doing both sterile and non-sterile, right? Okay. This one number is important for you to remember. In a manufacturing setting or compounding setting, we have what we call margin of error. Okay? So we say that's acceptable margin of error. Both sterile and non-sterile. In manufacturing, the acceptable margin of error, this came up on the board exam, is 5%, plus minus 5%. You should have done this in your weighing powders. Okay, plus minus 5%. What does that mean? Say, for example, you need to measure a total of, for easier numbers, I'll just use 100 grams of the active ingredient. Okay, plus 5% of this is 105 grams, correct? Minus 5% of this is 95 grams, correct? I'm talking total, okay? You need to measure 100 grams. So the acceptable weight for that particular drug, active ingredients, or measurement, or compound, or substance is between 95 grams to 105 grams. Okay? But of course, you want to be as accurate as possible. You want to make it to the dot grams. Right? Worst case scenario, when we're talking big measurements, this will come into play big time. Follow? The next number I'm going to tell you has something to do with capsules, which never came up on the PTCE, but this one did. I just know this because I've been teaching compounding for years. The acceptable margin of error for capsules. You get it? Are you following? Now here comes your IV bag. In IV bag, as a general rule, the acceptable overfill is 10%. Why is there an overfill? Because sometimes the prescription calls for you to extract that over first, okay, before you inject those drugs, and that's what we're going to do today. First page that you got today was Yukon. This is a sample. Yukon Health intravenous solution bag overfill. Okay. Any manufacturer supplied IV solution bag will contain overfill. It's not an exact 1000 ml. If the IV bag is a liter, it's not an exact 500 ml. If the IV bag is 500 ml. See the below chart that describes the possible amount of overfill contained in the various products that are used by JDH Pharmacy. These are just broad ranges determined by the company. There is no exact number of overfill for each IV solution bag, which means your manufacturer should be giving you a table like this. Okay, for the most popular manufacturer is B. Braun. Okay, a student of mine came here. He's an IV tech at Valley Hospital, and he was explaining to me. He just took the PTCE at that time when he came. Questions on overfill came up on his PTCE. Okay, and he's been using this a lot in his practice. Okay, if you notice, look at it. Your 100 ml labeled volume for a Baxter glass at that time, okay, is actually between 101 to 110. The real volume inside that bottle. For a Baxter is a common brand name as well, Baxter V. Braun. ViaFlex bag of 1000 ml, second row, second group, it has an overfill of about 30 to 70 ml. Did you see that? Okay, which means you have to remove, it's telling you, the manufacturer is telling you, you have to remove 58 ml for you to be using the correct volume of the bag. Is that clear? So this you don't calculate, this you don't come up with. This comes from manufacturer. And you have to be mindful that bags are not exactly filled. Okay? And the allowable overfill, hint, wink, wink, for IV bags is 10%. Now let's put that in practice. On a prescription, I'll erase this, huh? Those are 3 numbers. This 2 come up. This one I've never seen. Okay, but I mentioned. Called acceptable margin of error. Answer usually is 5%, unless it's talking. Mitomycin, you have that prescription, 40 milligram. So 0.5 milligram per ml, sterile water dilution. Added to 1000 ml normal saline, infused over 6 hours. Determine the CSP. What does CSP stand for? Very good. Compounded sterile product will result in an overfill that needs an adjustment of the above base solution. Assume, we have another number. Assume 50 ml overfill or 1000 ml. These are all your givens. First question, Show how to calculate the amount of sterile water diluent to be added. Show how to calculate the amount of sterile water to be added. We have a working equation. What do you think? Any guesses how we solve this problem? Show, first problem was how to calculate. First question is the amount of sterile water diluent to be added. So you see, anyone, any guess? Yes, Kaya. Yes, you're on the right track. So how? Tell me.
0.5 milligrams per ml equals 2,050 ml over or X over 1,050.
Not yet. You focus on this. Kyle, what about you? What's your guess? Correct. Is two? No, this is your XML. Step by step. Okay, and this should give you correct. That's the first answer to the question. Hint, hint, wink, wink. You have 1 page of overfill question on your final exam. How long is this? Oh. Studying. So let's go over it. Did you get it? Because this is your drug. You want to get the dilution of that. Next one, don't overthink, okay? Next problem is going to be show how you would estimate the amount of overfill. So the amount of overfill plus diluent. Don't overthink. The amount of overfill plus diluent. Look at the problem. The overfill is what? 50 ml, and the diluent is what? 80. So how much is that? Told you to not overthink, right? But if it asks you the total, then you add 1,000. If it asks you the total, you add 1,000. But it's only, it was clear. It just says, show how you would estimate the amount of overfill plus diluent. Now the next question, which leads to this, following this, what is the final volume of the IV solution in ml? I just told you the answer. It will be your answer to B plus what? So you're gonna have to put that in the 1,000 ml bag, correct? So this will be 1,130. That's the final volume. What's your IV bag again? 1,000 ml, correct? Supposedly. Okay. So the next question was, is this volume, you got on C, more or less than 10% of a liter? Because this is your liter. Is 1,130 ml more or less than 10%? Now you're going to figure out What's 10% of 1,000, correct? What's 10% of 1,000? 1,100 ml. Okay. So is this more or less than 10%? So this is more than 10%. That's the answer to B. But you can't answer that if you don't know what's 10% of 1,000. This is over 1,100. So if we are to follow that overfill rule of 10%, it failed on QC. However, it doesn't end there. There's a solution to that. What do? Based on your answer to D, which is more than 10%, okay? What adjustment in the volume of the base solution is necessary? Huh? What does this tell you? Your final volume ended up to 1,130 ml. But you still want to be accurate at getting your final volume to 1,000. So you have to do all these calculations before you proceed to the math. Okay? This told you right away that your bag is over what? How much is it over? Who says 30 ml? Who says 130 ml? This bag is over 130 ml because you still want to stick to your 1,000 ml bag as your final volume because that's where concentration is based on. Can you follow? What does this tell you? Before you start, you have to withdraw 130 ml from this bag because you know that it's over 130 ml before you inject everything that you calculated. So the final volume will still be 1,000. Follow? That's why don't proceed right away. Do the math first. Because you have to remember that you're going to inject all of these things and it will be more, even more, right? Be even more. So before you proceed, you want your solution to be a total of 1,000 ml or 1 liter still. You've calculated that there will be an excess of 130 ml. You withdraw that before you start compounding. That clear? And that is the answer to that last question. Questions? No questions? Tomorrow, I will go over Lilly equivalents again. There's one question on Lilly equivalents. Okay. And I'll throw in units conversion. To those of you who were here, you know that the conversion of insulin units to ml? Okay, what's a conversion? Correct. 100 units is 1 ml. You got to remember that. There are questions like that. Few. 100 units is 1 ml. I just don't want it to be, because our topic today is overfill and IV bags. Okay. I want you to go over everything. Review. Any questions? Any questions? Tomorrow there's a quiz. I'm saying that major topic is done. And then I'm just gonna go over units, insulin, like the not exactly part of this IV bag topic. How to calculate for Lilly equivalent. No questions? Ask me now. What? I don't know. You should know me by now, Camille. Yeah, at least it's not a pop quiz tomorrow. It's a quiz, announced one. Okay. So Miss L, how come we're pulling 130 ml, withdrawing it after our calculation? And this sample by Yukon Health said 58 ml because they figured it out for you. Withdraw 58 ml before you start if you're using 1,000 ml IV bag of the BioFlex bag. Okay. And then you proceed with your comment. So look for the table, for the sheet from the manufacturer, how much overfill is there. Tell us on the test tomorrow. What's the answer? What's on the test tomorrow? What's the answer? Everything. Exactly. Because we're done. The major topics are done. Others are just minor, like equivalent calculation and insulin calculation. And I think I put the insulin calculation video in your Blackboard to Jennifer's smile. I'm sure watched that already. When she panics, she watches all the videos. Just to be sure. She does. Mommies do that. Because they find all the answers in the world. Not this one, not this one. Okay, any questions? No questions? Quiz tomorrow. Quiz tomorrow, so speak up now. Is there one problem that you wanted solved? I'm ending the video. You want this?